So we now move on to Chapter 9, Conducting Experiments. The learning objectives for the chapter are to distinguish between straightforward and staged manipulations of an independent variable, to describe the three types of dependent variables, self-report, behavioral, and physiological, to discuss sensitivity of a dependent variable, contrasting floor effects and ceiling effects, to describe ways to control participant expectations and experimenter expectations, and to list the reasons for conducting pilot studies. Lastly, to describe the advantages of including a manipulation check in an experiment. And so, the previous chapters have really laid out what the foundation would be for researching and investigation. But this chapter, we're going to focus on, the practical aspects of what we would do to conduct an experiment and research. So, how do we select research participants, what you should consider when you're deciding how to manipulate the independent variable, and then what to worry about when you measure a variable. And what do you do when the study is completed? So, the focus of your study could be many different things. Children, college students, elderly adults, employees, pigeons, but the method used to select participants, it can have a profound effect on what the external validity of your study would be. So remember that external validity is defined as the extent to which results from a study can be generalized to other populations and settings. And really that's what we want to do, right? We want to have an experiment that we can then say the probability of this happening in the real world is highly likely, okay? So most research projects involve sampling research participants from a population of interest, right? We take a look at what the population of interest would be from us and would be for the experiment, and then we would sample from that using randomized sampling in order to then conduct an experiment, and through the randomized sampling we can then generalize that to the general population. Okay, so the population is composed of all individuals of interest to the researchers. And samples may be drawn from the population using probability sampling or non-probability sampling techniques. So when it's important to accurately describe the population, you must use probability sampling. And this is why probability sampling is so crucial when conducting scientific polls. So a lot of research, on the other hand, is more interested in testing hypotheses or behavior, or to detect, really attempting to detect whether X causes Y rather than to describe the population. So here the study focuses on the relationship between the variables being studied and tests of prediction derived from theories of behavior. So in those cases, the participants may be found in the easiest way possible using non-probability sampling methods such as convenience sampling. Okay, so you might then ask students in introductory psychology classes to participate. You obtain permission to distribute questionnaires to employees during the break time, or recruit participants using, Amazon, Mechanical Turk, or MTurk, okay? So nothing is wrong with such methods as long as you recognize that they affect the ability to generalize your results to some larger population. Okay, so in the last chapter, generalization, we examined the issues of generalizing from rather atypical samples of college students and other conveniently obtained research participants. Okay. So samples may be drawn from the population using probability sampling or non-probability sampling. And so when it is important to accurately describe the population, you must use probability sampling. And, in research that is more interested in testing hypotheses about behavior, the participants may be found more easily using non-probability sampling methods. So in general, increasing sample size, remember, increases the likelihood of statistically significant results. The larger the N, or the number of people that we test, the more likely that we're going to get statistically significant results, and then can say that it most likely will happen in the general population. Okay, so usually when we are having participants participate in an experiment, we have to supply participants with the information that's necessary for them to provide their informed consent to participate. And remember, we covered informed consent in, the ethics and behavioral research chapter. And it generally includes information about the underlying rationale for the study, why we're doing it, And sometimes the rationale given is completely truthful. Only rarely will you tell participants the actual hypothesis. It's just a general idea. We don't want to tell the participants exactly what we want to research, because then there potentially would be participant bias introduced. Okay, so we supply participants with the information necessary for them to provide their informed consent. And then we make the experiment settings plausible for participants. Okay, we make the experiment as close as we can to real world so the participants feel like the experimental setting is closely related. And then we can be fairly confident that there's internal validity, right? That the validity of the experiment is as close to real world setting as we would like to. So exactly how the variable is manipulated depends on the variable and the cost, practicality, and the ethics of the procedure. Okay. So there are different types of manipulations. Researchers are usually able to manipulate an independent variable with relative simplicity by presenting written, verbal, or visual material to the participants. So that's considered straightforward manipulations. So we manipulate variables with instructions and stimulus presentations. And the stimuli might be present verbally, in written form, videotape, or with a computer. Okay. So in looking at some examples of straightforward manipulation, okay, when you think of most memory research, it relies on straightforward manipulations. Okay, so for an example, Coulthard and Langdon, they displayed lists of words to participants and later measured recall. Okay, how many words they can remember. The word lists differed on phonological similarity. So some lists had words that sounded similar, such as cat, map, or pat, and other lists had dissimilar words, such as mop, or pen, or cow. Okay, and then they found that the lists with dissimilar words are recalled more accurately. Okay, fairly straightforward. Educational programs are most often straightforward as well. Okay, so, one researcher examined the effectiveness of 3 educational training programs designed to improve the jurors' ability to evaluate eyewitness testimony. So in that experiment, the subjects viewed a 15-minute slide presentation on a computer screen. Okay, and so the interview, identification, eyewitness training focused on 3 steps to analyze eyewitness evidence. So you would ask if the eyewitness interviews were done properly, you would ask if identification methods were proper, and then you would evaluate if the conditions of the crime scene allowed for an accurate identification. So a second presentation, the Biggers training, was a presentation of 5 eyewitness factors that the U.S. Supreme Court determined that should be used. And then they would obviously take a look at both of them and compare them. So the subjects in the interview, identification, eyewitness conditions were most likely to use the problems in reaching a verdict. Okay. Now, lastly, straightforward manipulation. Mazur et al. Looked at the effects of college teacher self-disclosure via Facebook on students' perceptions of teacher effectiveness. And for the study, students read one of 3 Facebook profiles, and then they were that were created for a volunteer teacher. Okay, one for each of the high, medium, and low disclosure conditions. So there would be one that had a high disclosure, a lot of information about the teacher, and then obviously down to low disclosure. So level of disclosure was manipulated in that. So by changing the number and nature of photographs, or the biographical information, or the favorite movies or books or quotes, etc. After viewing the profile to which the students were assigned, participants then rated the teacher on several dimensions. So higher disclosure resulted in a perception of greater caring and trustworthiness. However, disclosure was not related to perceptions of teacher competence. Again, straightforward manipulation. We manipulate one variable and then we test it. Okay. Stage manipulations are less straightforward. So sometimes it's necessary to stage events during the experiment in order to manipulate the independent variable successfully. And so when this occurs, the manipulation is called stage manipulation or event manipulation. Okay. And really what they're trying to do is try to create a psychological state in participants or simulate a real world situation. And often with the help of a confederate, okay, someone who's in on the experiment, who appears to be a participant. Okay. So the classic example is the Asch conformity experiment. So in that experiment, It's a conformity experiment. It provides another example of how confederates can be used. So he gathered people into groups and asked them to respond to a line judgment task, asking, such as the one that we'll look at in Figure 1. And they asked which of the 3 lines, the test lines, match the standard. Okay, so there'd be a standard line and there'd be 3 comparison lines. And we would ask the participant which one in the standard line is also shown in the comparison line. And although it appears to be a simple task, he made it more interesting by having several confederates announce the same incorrect judgment prior to asking the actual participant. Okay, and so this was repeated over a number of trials with different line judgments. And so he was able to demonstrate how easy it is to produce conformity. So participants conformed to the unanimous majority on many of the trials, even though the correct answer was so clear. Okay, so confederates can also be used in field experiments and laboratory research. Okay, so, Lee et al. Studied the impact of public sneezing on the perception of unrelated risks by having a accomplice either sneeze or not sneeze, which would be the control condition, while walking by someone in a public area in the university. And so a researcher then approached those people with a request to complete a questionnaire, which they described as a class project. Okay, so the questionnaire measured participants' perception of average Americans' risk of contracting a serious disease. And the researchers found that indeed being around a person who sneezes increased the self-reported feelings of risk of getting a disease. Okay, so in that regard, you can see a confederate is used, and there is a manipulation there to see how that sneeze, the person around you who sneezes, how that would affect someone's perception of potentially being infected by something. So here we see the standard line experiment by Ash. And you can see on the left, it would be the standard line, and we would ask the participants which on the right, 1, 2, or 3, matches the standard line. And it's quite clear that, number 2 is the exact length of the standard line. And as Ash showed, that if we had a confederate say that it's number 1, and be very confident around that answer, the participant would most likely unanimously agree that number 1 matched the standard line, even though it is quite clear to anyone that number 2 is, showing the effects of conformity. Okay, so the simplest experimental design usually has 2 levels of the independent variable. So when you plan the experiment, the researcher has to choose these levels. So the general principle that we would follow is to make the manipulation as strong as possible. So the strength of the manipulation matters. So a strong manipulation, what it will do is maximize the differences between the 2 groups and then increase the chances that the independent variable will have a statistically significant effect on the dependent variable. Okay, and this is especially important in the early stages of research. Okay, and there are 2 considerations. The strongest possible manipulation may entail a situation that rarely, if ever, occurs in the real world. Okay, and the manipulation should be as strong as possible within the bounds of ethics. So we can see here, a strong manipulation here, an independent variable here was at the bottom an amount of attitude similarity, and on the left, the dependent variable is the amount of liking, right? And so just to illustrate, suppose that you think there's a positive linear relationship between attitude similarity and liking. So, test the idea that birds of a feather flock together. And so when you conduct the experiment, you could arrange for participants to encounter a person who is a confederate. So in one group, the confederate and the participant would share similar attitudes. And the other group, the confederate and the participants, would have very dissimilar attitudes. So similarly, then is the independent variable and liking is the dependent variable. And so now you'd have to decide on the amount of similarity. Okay, so this figure really shows the hypothesized relationship between attitude similarity and liking at 10 different levels of similarity. So level 1 represents the least amount of similarity with no common attitudes. And level 10 is the greatest amount of similarity. So all attitudes are similar. And so in order to achieve the strongest manipulation, the participants in one group would encounter a confederate of level 1 similarity. Those in the other group would encounter a confederate at level 10 similarity. This would result in the greatest difference in the liking. So there would be really a 9-point difference between the 2. So a weaker manipulation would be using levels 4 and 7, for example, and it would really result in a smaller mean difference. And so, a strong manipulation is particularly important in the early stages of research, when the researcher is most interested in really looking to see, does this relationship even exist? And so the best way to do that is to use the lowest and compare it to the highest level of similarity. And that way we can say, okay, well, there might be something going on there. If we actually used a smaller interval, it may not pick up on something that might actually be there. Okay. And the last was that consideration of ethics. You need to show and try to look for a strong as possible manipulation, but within the bounds of ethics. Okay. So a strong manipulation of, let's say, fear of anxiety, for example, it actually may not be possible because of the potential physical and psychological harm to the participants that might be in the experiment. So you would probably use a lesser level of anxiety introduced into the experiment. And lastly, the cost of the manipulation. Manipulation that uses straightforward presentation of written or verbal material is less costly than a complex stage experiment or manipulation. So we always want to, cost is always going to be a factor. So, the dependent variable in most experiments is one of 3 general types: self-report, behavioral, or physiological. Okay. In self-reports, we would measure the required participants to describe themselves. Okay. And it's the most commonly used rating scales are those with descriptive anchors or endpoints. Okay. So, example, how likely is it that Jack is guilty? Okay. And it would be very unlikely to very likely. Okay. So there are endpoints on either end that anchor the actual question. When it comes to behavioral measures, there are direct observations of behaviors. So as with self-reports, it's possible to measure an almost endless number of behaviors. And sometimes the researcher might record whether a given behavior occurs, for example, whether an individual responds to a request for help or makes an error on a test or chooses to engage in one activity rather than another. Okay, so often researchers need to quantify observed behavior, such as the rate of a behavior, how many times the behavior occurs in a given time, the reaction time, so how quickly a response occurs after a stimulus, such as sound, a light, or a word, and duration, how long does the behavior persist? Okay, so again, often observed behaviors have to be quantified in terms of rate, reaction time, and duration. And then sometimes the behavioral measure is not an actual behavior, but a behavioral intention or choice. Okay. So in a study of aggression, let's say, after being provoked by another subject, participants decide how much hot sauce the other subject would have to consume later in the study. They did not actually pour the hot sauce, but they did commit to an action rather than simply indicate their feelings about the other participant. Okay. And another types of measurement would be a physiological measure. So the recordings of responses of the body. Okay. And there are several, galvanic skin response really uses the electrical conductance of the skin. Okay. When we look at electromyogram, it actually measures and uses the electrical activity of muscles, and it measures it. An EEG measures electrical activity in the brain, right? So we can actually see what changes are happening in the brain. In an MRI, it would actually scan body structures, including the brain, to create images that we can then measure and take a look at and actually maybe see descriptive changes in somebody's brain functioning. And lastly, an fMRI measures blood flow to areas of the brain to create an image or electrical activity, because we know that, more electrical activity equals more blood flow. So if there's more blood flow, there's more electrical, more activation. So we could give somebody an experiment and measure their response and see, well, was there activation based on the manipulation of the independent variable? So, a variable can be measured in a variety of concrete ways. And it's useful to know whether the same independent variable affects some measures but not others. And so research may also be interested in the effects of an independent variable on several different behaviors. So with more than one dependent measure, the question of order arises. So when we look at the sensitivity of the dependent variable should be sensitive enough to detect differences between groups. Okay, so a measure of liking that asks, do you like this person, with only a simple yes or no, response alternative is less sensitive than one that asks, how much do you like this person on a 5 or 7 point scale? So with the first measure, people may tend to be nice and say yes, or they just say yes or no, but there's no real understanding of, what the variation is in there. What is it? So it needs to be, the dependent variable, it should be sensitive enough to detect differences between groups rather than just putting them in one or the other. Okay. So, the issue of sensitivity is particularly important when measuring human performance. So, memory can be measured with different types of measurement, like recall, recognition, or reaction time. Or cognitive task performance might be measured by examining speed or maybe the number of errors that the actual participant makes in, let's say, a proofreading task. So, such tasks vary in their difficulty. Sometimes a task is so easy that everyone does well, regardless of the condition that is manipulated by the independent variable. And that result is what's called the ceiling effect. So the independent variable appears to have no effect on the dependent measure only because participants quickly reach the maximum performance level. They just do very, very well. And the opposite problem occurs when a task is so difficult that nobody gets the answer right. And so we might actually think, oh, well, okay, well, this experiment didn't work, when really the task was just way too difficult for the participants. And the cost of measures. Some measures may be more costly than others. Paper and pencil or self-report measures are generally fairly inexpensive. But, measures that requires maybe training the observer or elaborate equipment may become quite costly. So for many types, researchers need resources from the university or outside agencies in order to conduct their experiments. So, when participants form expectations about the hypothesis, they do what is necessary to confirm the hypothesis. And so deception sometimes can mitigate this effect. So, as we spoke about previously, experimenters generally don't wish to inform participants about what exactly they're measuring, so the specific hypothesis being studied. And, the reason for this lies in the problem of what we call demand characteristics, which is any feature of the experiment that might inform the participants of what the purpose of the study actually is. And the concern is that, if a participant form expectations about the hypothesis of the study, it might actually change the way that they perform or their responses. So for example, if you were studying the relationship between political orientation and homophobia, participants might figure out the hypothesis and behave accordingly to what they think you want instead of what actually being truthful. Okay. So one way to control for demand characteristics is to use deception. To make participants think that the experiment is studying one thing when actually it's studying something else, with still staying in the bounds of informed consent, informing generally what their participants are going to be exposed to without giving away the actual purpose of the study. So the experimenter can devise elaborate cover stories to explain the purpose of the study to disguise what actually is being studied. And they might actually attempt to disguise the dependent variable by using an obtrusive measure, so something that we put in there, and we call that a filler items on questionnaires. So what we actually want to study might be in the questionnaire, but there might be other questions that will disguise the actual questions that we would be actually measuring. So, one of the things that's important is to control the participant expectations. If we just administer an apparent treatment, it may be sufficient to cause an observed improvement in behavior. And that phenomenon is known as a placebo effect. Okay, so really just letting somebody in on an experiment might actually cause some kind of change in the participant. Okay, so we use placebos a lot in medication studies, where one group is given a sugar pill and the others are given the actual medication. And we take a look at, is there improvement? Just by allowing a participant to be involved in the study, whether or not they get the actual medication or not, being involved in the study alone could actually cause some effect. Okay, so to control for this, researchers use a placebo group. Participants in a drug study who receive an inert substance instead of the experimental drug. And typically what happens though, is that, one will get the placebo, one will get the actual medication. And then eventually the placebo group will also get the medication as well, because it doesn't really seem fair to not give them a potential life-saving medication. Okay. So if the placebo group improves as much as the experimental group, all improvement could be caused by the placebo effect. Just being involved in the study creates a difference in their self-report. Placebo control groups have ethical implications, and those receiving the placebo are due the actual treatment if proven effective. So if you are in the placebo group and the treatment's proven effective, you will get the drug as well, in order to be ethical. So one of the things we have to look at is expectancy effects, or what we call experimental bias. And this is the impact of an experimental bias on the outcome of a research study. And so really what we're talking about is that the experimenter might unintentionally treat participants differently in the various conditions of a study. Okay. And so when recording behaviors, there may be subtle differences in how the researcher interprets and records them as well. And so in order to control for that, there are ways to minimize what we call those expectancy effects. One is a single blind experiment where the participant is unaware of whether a placebo or the actual drug is being administered. Okay, so you don't know which group is which. Or a double blind experiment. Neither the participant nor the experimenter knows whether the placebo or actual treatment is being given. And that way, we can be fairly sure that there is less experimental bias and less expectancy effects, because nobody, in the single blind, the participant's unaware. Whereas in a double blind, they both are unaware, so we can be doubly sure that there are no expectancy effects. So lastly, we look at planning considerations. So research proposals are written after the researcher has put considerable thought into planning a study. Okay. So sometimes we may do a pilot study where the researcher does a trial run with a small number of participants, in order to obviously reduce costs as well, just to see if there is some small effect. And then we would, conduct the experiment again with a greater number of participants, because remember, a greater number of participants equals a greater likelihood of significant results, which means a greater reliability that we could say that whatever we're seeing in the experiment is now being generalized to the population. Okay. Sometimes we use a manipulation check, which is really an attempt to directly measure whether the independent variable manipulation has the intended effect on the participants. So, a debriefing session provides an opportunity for researchers to interact with the participants after the data has been collected. And a lot of times early on in research, we would do that to see how the participant felt. Was there small things that need to be changed in the experiment when we, or the pilot study, so that we can change those things and have a better study when we have a greater number of participants involved. And lastly, when we look at analyzing and interpreting results, statistical analysis are carried out to allow the researcher to examine and interpret the pattern of results. Statistical analysis of the data are carried out to allow the researcher to then examine and interpret the pattern results that are obtained in the study. And, this analysis helps the researcher decide whether there really is a relationship between the independent and dependent variable. Just because we see a greater number of participants answering one way or another doesn't mean it's relevant, doesn't mean it's significant. Okay. So really what that analysis is going to do is confirm maybe some of the things you might be actually seeing. And so the logic underlying the use of statistical tests is further discussed in the chapter Understanding Research Results, but it's not the purpose. And so that's, the purpose of this chapter, but we will take a look at it in another chapter. And one of the important parts of research is really communicating those research results to other researchers. Right? Meetings sponsored by professional associations give researchers a chance to present their findings to other researchers and the public. And so, the Canadian Psychological Association and the American Psychological Association meets yearly. You can submit your papers. And one of the great things about it is when you give your research at these conferences and present them, you get feedback by other people in the area would say, hey, have you thought about this? Have you looked at this? And it is scrutinized to a certain extent, but also disseminates that information, because that's part of the scientific method, right? Is to disseminate information, and maybe that would spark another researcher to say, oh, I kind of like that experiment, or I think I could do it better and change it slightly. Lastly, research papers submitted to journals are subject to peer review. So as many as 90% of papers submitted to more prestigious journals are rejected. And it's a panel of us that would take a look at the paper and scrutinize it. How was it done? Was the statistical tests used relevant? Were they the right ones to use? Was there methods that were maybe not as great? Did the conclusions they reached, does that make sense based on how they conducted the experiment and, what the results were? And so that is a really, really important thing when you're doing research, is that, or even just writing papers in college and university, is to make sure that the papers you are using are peer reviewed, which means they are scrutinized heavily by major people that are long-standing in the field, that know a lot about the subject. And that way we can eliminate some other research that's maybe not so great, or, in current days, a little bit of fake news that we see quite a bit of, or people that, give their expert opinion based on, no research whatsoever. So we move on to chapter 11, which is single case, quasi-experimental, and understanding developmental research. And so the learning objectives of this chapter are to describe single case experimental design and discuss reasons to use this design, to describe the one group post-test only design, to describe the one group pre-test, post-test design and the associated threats to internal validity that may occur. So history, maturation, testing, instrument decay, and regression towards the mean. And to describe the non-equivalent control group design and non-equivalent control group pre-test, post-test design, and to discuss the advantage of having a control group. To distinguish between the interrupted time series design and control series design, to describe cross-sectional, longitudinal, and sequential research designs, including the advantages and disadvantages of each design, and to define the cohort effect. So, in the classic post-test only experimental design, participants are randomly assigned to the independent variable, the conditions, and a dependent variable is then measured. And the responses on the dependent variable are measured and then compared to determine whether the independent variable had an effect on the dependent variable. Okay, because all the variables are held constant, differences on the dependent variable must then be due to the effect of the independent variable. And so this design has a high internal validity. So we are very confident at that point that the independent variable caused the observed response that we are seeing on the dependent variable. And so you'll often encounter this experimental design when you explore research in behavioral sciences. But other research designs have been devised to address specific research problems that we've found. Okay, and that's what this chapter really focuses on, is, the three of these research designs. So first, we will look at the instance in which the effect of an independent variable must be inferred from an experiment with only one participant. So single case experimental design. Okay. And that's what we'll look at first. And then second, we'll describe pre-experimental and quasi-experimental designs that you can potentially consider if it's not possible to use one of the true experimental design. Okay. And third, we're going to consider a research design for studying changes that occur with age. Okay. So in a single case experimental design, it's traditionally been called a single subject design. Okay. And this allows cause and effect inferences based on data from one or a small number of research participants. It's also called a single subject design or a small n design. Remember, n equals the number of participants typically. And so really the subject's behavior is measured during a baseline period, and then it is followed by experimental manipulation and then continued measurement. And the basic issue in single case experiments is how to determine that the manipulation of the independent variable had an effect. So, single case experiments were developed from the need to determine whether an experimental manipulation had an effect on a single research participant. And so in that single case design, the subject's behavior is measured over time during a baseline control period. And then the treatment period follows, in which the experimental manipulation is introduced, and then the subject's behavior continues to be observed. So really what that means is that if there is a change in the subject's behavior from baseline to the treatment periods, it then provides evidence for the effectiveness of the manipulation. But there is a problem, is that there could be many explanations for the change other than the experimental treatment. So really what we're talking about is there could be alternate explanations. And so, for example, some other event may have coincided with the introduction of the treatment. And so the single case design described in the following section that we're going to talk about addresses this problem. So, as we discussed, the basic issue in single case experiments is how to determine that the manipulation of the independent variable actually had an effect. One method is to demonstrate the reversibility of the manipulation. So a simple reverse design takes the following form. You have a baseline period, you have B, a treatment period, and then a baseline period again. Okay, so the basic reversal design is called an ABA design. Okay, so the behavior is observed during the baseline control A period. It's then again during the treatment B period, and also during a second baseline period after the experiment treatment has been then removed. Okay. Sometimes we call this the withdrawal design in recognition of the fact that the treatment is removed or withdrawn. Okay, so the effect, let's say the effect of reinforcement procedures on a child's academic performance could be assessed with that ABA design. So the number of correct homework problems could be measured each day during the baseline. A reinforcement treatment procedure would then be introduced in which the child receives stars for actually getting the correct, stars for correct problems. And the stars could be accumulated in exchange for toys or candies. Later, this treatment would be discontinued during a second baseline A period, that withdrawal period. And so hypothetical data from such an experiment are then shown here, where we would have the baseline, where we just measure how often they get the correct. Then we have the treatment period, which is the addition of the toys. So you can see here that the behavior increased. And then we would remove that effect of giving the toys and see how that baseline then comes back to normal. Okay. So, some treatments do produce an immediate change in behavior, but, other variables may require longer time to show an impact. And so the ABA design can be greatly improved by extending it to an ABAB design, in which the experimental treatment is introduced a second time, or even an ABAB design that then allows for, the treatment, baseline treatment, baseline treatment, baseline treatment. And then we would look at each of those sections to see, is there an improvement? Is there an effect on that design? Okay. But there are some issues with the ABAB design. Okay. So, the observed reversal sometimes might be due to random fluctuations in the child's behavior in this previous right here. So that is one possible problem. So it is possible that the increase that we are seeing could be due to another fluctuating event. It could coincide with, let's say, the upcoming child's birthday. That could actually cause the change. Okay. So those possibilities are much less likely if the treatment has been shown to have an effect 2 or more times. Okay, so random or coincidental events are unlikely to be responsible for both reversals. Okay, but the second problem is ethical. Okay, it does not seem right to end the design with the withdrawal of a treatment that might be very beneficial for the participants. So using the ABAB design provides the opportunity to observe a second reversal when the treatment is introduced again. Okay. So the logic of the reversal design can also be applied to behaviors observed in single settings. Okay, so the textbook talks about Casbrough and Bailey, where they examine the effectiveness of a procedure designed to increase the use of designated drivers in a bar. And so the percentage of bar patrons either serving as or being with a designated driver were recorded over a baseline period of 2 weeks. So a procedure to increase the use of designated drivers was then implemented during the treatment phase. So designated drivers receive $5 gas card, and the driver and passengers receive free pizza on their way out of the bar. So the pizza and the gas incentive were discontinued during the final phase of the study. So the percentage of bar patrons engaged in designated drivers arrangements increased substantially during the treatment phase, but returned to baseline levels after the incentives were withdrawn. So, it may have occurred to you that a reversal of some behaviors may be impossible or maybe even unethical. So, for example, it would be unethical to reverse treatments that reduce dangerous or illegal behaviors, such as indecent exposure or alcoholism, even if the possibility exists that a second introduction of the treatment effect might be effective. So other treatments might produce a long-lasting change in behavior that might actually not be reversible. So in that case, multiple measures over time can be made before and after the manipulation. So if the manipulation is effective, a change in the behavior will be immediately observed, and the change will continue to be reflected in further measures. So in multiple baseline design, the effectiveness of the treatment is demonstrated when a behavior changes only after the manipulation is introduced. So to demonstrate the effectiveness of the treatment, such a change must be observed under multiple circumstances to rule out the possibility of that the other events were then possible. Okay, so there are several variations of the baseline design. Okay, so in multiple baseline across subjects, the behavior of several subjects is measured over time for each subject. Okay, the manipulation is introduced at a different point in time. So here in figure 2 shows data from a hypothetical smoking reduction experiment with 3 subjects. And I want you to notice that the introduction of the manipulation was followed by a change in behavior for each subject. But because this change occurred across all individuals and the manipulation was introduced at a different time for each subject, we can rule out explanations that are based on chance or historical events or so on. You can see that the change happens at a different time, even though the treatment is given at different times as well. So, in a multiple baseline across behaviors, several different behaviors of a single subject are measured over time. And then at different times, the same manipulation is applied to each behavior. Okay. The third variation is the multiple baseline across situations, in which the same behavior is measured in different settings, such as at home or let's say at work. And again, a manipulation is introduced at a different time in each of the settings, with the expectation that a change in the behavior in each setting will occur only after the manipulation. So we can rule out setting as a potential confounding variable. Okay. So the procedures for use with a single subject can be replicated with other subjects, and this would greatly enhance the generalizability of the results. So usually reports of research that employ single case experimental procedures do present the results from several subjects, and often in several settings. Okay, so traditional single case research presents research from each subject individually to avoid masking differences between the participants. So quasi-experimental designs address the need to study the effect of an independent variable in a setting in which the control features of true experimental designs can't be achieved. So a quasi-experimental design allows us to examine the impact of an independent variable on a dependent variable, but causal inferences is much more difficult because quasi-experiments lack important features of true experiments, such as random assignment to conditions. Okay, so let's take a look at quasi-experimental design. So there are many different types of quasi-experimental design. Okay, only 6 designs are going to be described here in this chapter. So, when you read about each design, in the textbook, I want you to compare the design features and problems with the randomized true experimental designs described in the chapter. Okay, So we'll start out with the simplest, one group post-test only design. So, the textbook talks about, suppose you want to investigate whether sitting close to a stranger will cause the stranger to move away. So you might try sitting next to a number of strangers and measure the number of seconds that elapse before they leave. So your design would look like this. There's a participant, the independent variable is sitting next to the stranger, and a dependent variable, the time until the stranger leaves. Okay. Now, suppose that the average amount of time before the people leave is 9.6 seconds. Unfortunately, this finding is not interpretable. You don't know whether they would have stayed longer if you had not sat down, or whether they would have stayed 9.6 seconds anyway. So it is even possible that they would have left sooner if you had not sat down. Perhaps maybe they liked you. So the one group post-test only design is called a one-shot case study, and it lacks a crucial element of a true experiment, a control or a comparison group. Okay, so there must be some sort of comparison condition to enable you to interpret your results. The only group post-test only design with its missing comparison group has serious deficiencies in the context of designing an internally valid experiment that will allow you to actually draw causal inferences about the effect of an independent variable or on a dependent variable. So you might wonder whether the design was used at all. So you might see this type of design used as evidence for the effectiveness of a program. So employees in a company, they might actually participate in a 4-hour information session on emergency procedures. And then at the end of the program, they complete a knowledge test on whether their average score is 90% or not. This result is then used to conclude that the program is successful in educating the employees on that safety program. Okay. But that study lacks internal validity or ability to conclude that the independent variable had an effect on the dependent variable. And so with that design, we don't know if the score of the dependent variable would have been equal, lower, or even higher with the program. And so the reason such results are sometimes accepted is that we have an implicit idea of how a control group would perform. But really what we need is comparison data. So one way to obtain a comparison group is to measure participants before the manipulation, so a pretest. You give them the pretest, okay? Then you would have some kind of condition or training, and then you'd be able to test them again, right? So an index of change from the pretest to the post-test could be then computed. Although this one group pretest post design sounds fine, there are obviously some major problems with it. Okay, so let's take a look at the example in the textbook. Suppose you want to test the hypothesis that a relaxation training program will result in a reduction in cigarette smoking. Using the one group pretest post-test design, you would select a group of people who smoke, administer a measure of smoking, have them go through relaxation training, and then re-administer the smoking measure. And so your design would look like this. The participants, the dependent variable, the pretest would be the smoking measure. Then you have the independent variable, which would be the training program. And then you would test them again on the dependent variable, the post-test, to see if there was a change. So if you did find a reduction in smoking, you actually could not assume that the result was due to the relaxation training program. This design has failed to take into account several alternative explanations. So those alternate explanations are threats to what we call the internal validity of the experiment of studies using this design, and they include history, maturation, testing, instrument decay, and regression towards the mean, which we will take a look at. So these are potential threats to internal validity. So history refers to the events that occur between the first and second measurements, but it's not part of the manipulation. So any event that might happen is confounded with the manipulation. So suppose that a famous person dies of lung cancer during the time between the first and second measure. This event alone, and not the relaxation training, could be responsible for the reduction in smoking. Okay. History effects can be caused by virtually any confounding event that occurs at the same time as the experimental manipulation. So maturation. So because people change over time, in a brief period, they become bored or fatigued or maybe wiser or hungrier. Over a longer period, children tend to become more coordinated or analytical, and so on and so on. So any changes that occur systematically over time are called maturation effects. So maturation could be a problem in the smoking reduction example if people generally become more concerned about their health as they get older. Okay, so testing. Testing becomes a problem if simply taking the pretest changes the participant's behavior. Okay, so this is the problem of testing effects. So for example, the smoking measure might require people to keep a diary in which they note every cigarette smoked during the day. So simply keeping track of their smoking might be sufficient enough to cause a reduction in the number of cigarettes that the person smokes. And so the reduction found on the post-test could be the result of taking the pretest or measuring the number of smokes that you had rather than the program itself. So in other contexts, taking a pretest may sensitize people to the purpose also of the experiment and make them more adept at a skill being tested. Okay, so instrument decay. So the basic characteristics of the measuring instrument sometimes change over time, and it's called instrument decay. So consider sources of instrument decay when humans observers are used to measure behavior. So over time, the observer actually might become gain skill or become tired, or they change the standards on which the observations are then based. So in a smoking example, participants might be highly motivated to record all cigarettes smoked during the pretest when the task is new and interesting. But as the time goes on, by the time the post-test is given, they may be tired of the task or sometimes forget to record a cigarette. So such instrument decay would lead to an apparent reduction in cigarette smoking. Lastly, we're sometimes called statistical regression or regression towards the mean, is likely to occur when participants are selected because they score extremely high or low on some variable, right? We put them in the groups, high or low. When they are tested again, their scores tend to change in the direction of the mean. So extremely high scores are likely to become lower, closer to the mean, and extremely low scores are likely to become higher, again, closer to the mean. So regression towards the mean would be a problem in the smoking experiment if participants were selected because they were initially found to be extremely heavy smokers. And by choosing people for the program who scored highest on the pretest, the researchers might have actually selected many participants for whatever reason smoking much more than usual at the particular time when the measure was administered. And so, those people were smoking much more than usual will likely be smoking less when their smoking is measured again. So, if we compare the overall amount of smoking before and after the program, it will appear that people are smoking less. But really, you've just picked really extreme groups to start with that will more likely regress towards the mean. So, the non-equivalent control group design employs a separate control group. But the participants in the two conditions, the experimental group and the control group, are not equivalent. So in other words, the two groups are not the result of random assignment. Really important there. Okay. The differences become a confounding variable that provides an alternative explanation for the results. And this problem is called selection differences or selection bias. And it usually occurs when participants who form the two groups in the experiment are chosen from existing natural groups. If the relaxation training program is studied with the non-equivalent control group design, the design will then look like this. So the participants in the first group are given the smoking frequency measure after completing the relaxation training. And the people in the second group do not participate in any program. So in this design, the researcher does not have control over which participants are in each group. So suppose, for example, that the study is conducted in a division of a large company. all the employees who smoke are identified and recruited to participate in the training program. So the people who volunteer for the program are in the experimental group, and the people in the control group are simply smokers who do not sign up for the training at all. The problem with selection differences arise because smokers who choose to participate may differ in some important way from those who do not. So for instance, they may already be light smokers compared with the others and are more confident that a program can help them. So any differences between the groups on the smoking measure would be reflect pre-existing differences rather than the effect of the relaxation training program. Okay. So the non-equivalent control group post-test only design can be greatly improved if a pre-test is given. And so when this is done, we have a non-equivalent control group pre-test post-test design. And one of the most useful quasi-experimental designs, it can be diagrammed as followed here. And so this design is similar to the pre-test post-test design described. However, this is not a true experimental design because, again, assignments to groups is not random. The two groups may not be equivalent. Okay, but we have the advantage, however, of knowing the pre-test score. So then we can see whether the groups were the same on the pre-test. And so even if the groups are not equivalent, we can look at changes in scores from the pretest and the post-test. If the independent variable has an effect, the experimental group should show a greater change than the control group. So in propensity score matching, it's really a method of matching participants from non-equivalent groups based on their similarity across a number of measures. Okay, and so for example, people who decide to attend an alcohol screening event may differ from those who are interested in a health screening. So perhaps people at the health screening are in fact healthier than the alcohol screening participants. And so to make these groups equivalent on a variable such as health is to match participants on a condition of a measure of health. Okay. So what we might do is give them an actual measure of health and then match them based on those. It may not be random, right? But it does give us more comparable groups. It mitigates the disadvantage of studying non-equivalent groups. Okay, so, in interrupted time series design, it examines the dependent variable over an extended period of time before and after the independent variable is implemented. Okay, so very simple, there's going to be, an extended period of time before and after the independent variable is implemented, a much longer experiment. But it is vulnerable to interpretation problems, so possible regression to the mean as we talked about previously. In a control series design, an extension of the interrupted time series design in which there is a comparison or control group as well. But it involves finding a similar population that did not receive the manipulation being studied, which can sometimes be difficult. So here we have an interrupted time design where you can see there's a period of time over years where there's no treatment. A treatment is then given, and then, we follow over a period of years to see what happens. And then here, we have a control series design where there is a control group where we just follow over time, and then one where, we're two groups, one being the control group, we follow over time, and then where a treatment is added. In this, it is the Connecticut traffic fatality rate, and that is the solid colored line, with the fatality rate of the comparable states, which is the dotted line, right? That would be your control group. So, developmental psychologists use three methods to study changes in people as they age: cross-sectional method, longitudinal method, and sequential method. In cross-sectional method, persons or different age groups are measured at the same point in time. So using the cross-sectional method, you might want to actually study people who are currently 20, 30, 40, and 50 years old. And the participants in your study would be given the same, let's say, a computer learning task to see how the ability to learn a computer application changes as people grow older. The problem is that there are some issues with it in that there could be cohort effects, which means that people that are 50 grew up very differently than those that are 20, right? Those that are 20 might have more likelihood of knowing how a computer works. So in a longitudinal method, the same group of people is observed at different points in time as they grow older. Okay, so the famous longitudinal study is the terminal life cycle study, in which began by Stanford psychologist Lewis Terman. And so he studied 1,500 California school children who had intelligent test scores of at least 135, so pretty high intelligence. The participants, who called themselves termites, were initially measured on numerous aspects of their cognitive and social development. Okay. And Terman and his colleagues continued studying these termites from childhood through adulthood. Okay, so Terman's successors at Stanford have continued to track these termites, and the study had provided a rich description of the lives of highly intelligent individuals, and disconfirmed a lot of stereotypes of high intelligence. For example, the termites were very well adjusted, both socially and emotionally. And so the data have now been archived for the use by other researchers. And, so again, we're following people over a very long period of time. So a comparison between the longitudinal and cross-sectional methods is to use the sequential method. And this method, along with the cross-sectional and longitudinal method, is illustrated here in figure 5 here. And so, in the figure, the goal of the study here is to minimally compare 55 and 65-year-olds. So the first phase of the sequential method begins with the cross-sectional method. So for example, you would study groups 55 and 65 years old. And then these individuals are then studied using the longitudinal method, with each individual tested at least one more time. Okay, so the comparison in the example in the group, in the textbook, Orth et al. Studied the development of self-esteem over time using just such a sequential method. So using data from the Americans Changing Lives study, Orth and his colleagues identified 6 different age cohorts. So 25 to 34, 35 to 44, 45 to 54. Okay. 55 to 64, 65 to 74, and 75 and above, and examined their self-esteem ratings from 1986 to 2002. And so they were interested in changes in self-esteem for participants at various ages over time. And so their findings provided an interesting picture of how self-esteem changes over time. And they found that self-esteem gradually increases from age 25 to around age 60, and then declines in later years. So, you imagine how many years it would take if this was conducted as a full longitudinal study. So, this method takes fewer years and less effort to complete than a longitudinal study. And the researcher reaps the immediate rewards because the data on the different age groups are available in the first year of the other study. On the other hand, the participants are not followed over the entire time span as they would be in a full longitudinal investigation. So no one in Orth's study was followed from age 25 to 100. And so, the cross-sectional method is relatively inexpensive, and it allows comparisons to be made quickly. So researchers can only infer that any differences found are due to age. Differences may actually be due to cohort effects. So a cohort is a group of people born at the same time and exposed to the same societal events. So a cohort effect is, the differences that we find among age groups that can be attributed to social, cultural, economic, or political differences rather than just to the effect of age. The longitudinal method is the only way to conclusively study changes in people as they age, because it controls for cohort effects. But it is expensive and difficult to carry out and takes a long time to yield results. You've got to be in it to win it. The sequential method takes less time and effort than the longitudinal method and yields some results right away. It does provide some information on changes in people as they age, but it does not provide information as complete as a longitudinal study then can offer.